So this is a question from the chapter Pair of Linear Equations in Two Variables. A boat goes 30 kilometers upstream and 44 kilometers downstream in 10 hours. In 13 hours it can go 40 kilometers upstream and 55 kilometers downstream. Determine the speed of the stream and that of the boat in still water. So how do you approach this question? The first step is to figure out the unknowns in the question. That is, figure out what is the question asking us to look for. The question is asking us to determine two things. First is the speed of the stream. Second is the speed of the boat in still water. These two unknowns can be represented by two variables, two different variables. In mathematics, for denoting or representing unknown quantities or unknown parameters, we use variables. In this particular question, we have two unknowns, or two unknown parameters. First is the speed of the stream, second is the speed of the boat in still water. So let us denote the speed of the stream by y, and let us denote the speed of the boat in still water using the variable x. Now what will be the units for these two variables? To figure out the units, let's go back to the question. If you look carefully at the question, all distances are given in kilometers and time is mentioned in hours. So the units for both x and y will be kilometers per hour, as both of them denote the speeds. Next, let us understand the dynamics of a boat moving on a stream of water. Two components come into play when a boat moves on a stream of water. First is the speed of the boat in still water, and second is the speed of the stream. And how does this affect the overall speed of the boat? So when you are traveling or you're moving downstream on a boat, the stream is helping the boat in moving forward, since both the boat and the stream are going in the same direction. The effective speed of the boat, so the effective speed of the boat will be x plus y kilometers per hour. Similarly, in the scenario where you're moving upstream, what happens is the stream is pushing the boat backwards. So the flow of the current or flow of the stream is against the movement of the boat. So whereas when you were moving downstream, the speed of the stream was helping you move forward, when you're moving upstream, the speed of the stream is slowing you down. So the speed of the boat when it goes upstream will be equal to, since the boat is going against the stream in the opposite direction of the stream, it will slow you down. So the effective speed of the boat upstream will be x minus y kilometers per hour. For the next phase, we need a pair of linear equations that will help us reach the solution. So if you look at the question carefully, the first two statements will help us figure out the two linear equations. The first statement, a boat goes 30 kilometers upstream and 44 kilometers downstream in 10 hours, can be represented in the form of a linear equation. Similarly, the second statement, in 13 hours it can go 40 kilometers upstream and 55 kilometers downstream, can also be represented in the form of a linear equation. Before we get to that, let us review the formula that connects speed, distance and time. Speed is equal to distance upon time, or since both these statements give us the total amount of time a boat takes to go a certain number of kilometers upstream and downstream, we will think in terms of the time. So T is equal to distance upon speed. So let us consider the first statement and form a linear equation corresponding to the first statement. So a boat goes 30 kilometers upstream. If you represent this part of the sentence mathematically, we can write, let's denote the time taken by the boat to go upstream by T1. So distance upon speed, which is equal to, distance is 30 kilometers and speed, this is upstream. The speed of the boat upstream is equal to x minus y. This is first part of our equation. Then next, plus, let us denote the time taken by the boat to travel 44 kilometers downstream by T2. So T2 is equal to distance upon speed, which is equal to, distance is travel 44 kilometers and speed, the boat is going downstream. The speed of the boat downstream, x plus y. And how much time does it take total to go 30 kilometers upstream and 44 kilometers downstream? 10 hours. So this total time corresponding to the first statement is equal to T1 plus T2, time taken by the boat to go 30 kilometers upstream and time taken by the boat to go 44 kilometers downstream, which will be with this you have your first linear equation. (30 upon x minus y plus 44 upon x plus y is equal to 10. Similarly, using the second statement, let's keep this at the bottom for quick reference. Second, let's denote the time taken by the boat to go 40 kilometers upstream by T3. T3 is equal to d upon s, which is distance is equal to 40 upon s, speed of the boat upstream. Boat goes upstream at the rate x minus y kilometers per hour. And let's denote the time taken by the boat to go 55 kilometers downstream by T4. T4 is equal to d upon s, which is equal to 55, the distance upon downstream, speed of the boat going downstream, x plus y. The total time is equal to T3 plus T4, which is equal to 13 hours. So the second equation will be 40 upon x minus y plus 55 upon x plus y is equal to 13. So now with this, the two linear equations, the pair of linear equations that will help us figure out the values of the two variables in question. Final twist to the question, a small substitution will convert these two linear equations into a pair of linear equations of the form a1x plus b1y plus c is equal to 0 that we usually come across and help us reach the solution quickly. So the substitution is denote these two terms 1 upon x minus y, 1 upon x plus y with two new variables. Let's denote 1 upon x minus y as u and 1 upon x plus y with v. With this, you have your first equation becomes 30 u. So this will become 44v is equal to 10. Similarly, the second equation will become while substituting, you have to be very careful. Now if you look at these two equations, these are of the form a1x plus b1y plus c is equal to 0. Only difference is the constant is on the right hand side. In the form, the constant is also on the left hand side. So if you take these constants to the left hand side, it will be exactly similar to the form. Now you can use any method to solve these two linear equations and figure out the values of u and v. Let's see how we can do it. Now let us solve these two linear equations using the method of elimination. You can use any method. I'll go with elimination. So for the elimination method to work, one of the variables must have the same coefficient. So let's try and make the coefficient of u equal. For that, let's multiply the first equation by 4 and the second equation by 3. So that 4 times 30 will give us 120u. Similarly, 4 times 44 will give us 4 is 16, 4 is 16, 1 carries 176v is equal to 40. Remember, you have to multiply all the terms in the equation with 4. Hence putting a bracket helps so that we don't forget or miss out on multiplying all the terms. in the equation. And the second equation will become 3 times 4 is 12, 0, 120u plus 3 times 5 is 15, 3 times 15, 165u is equal to 3 times 13 is 39. So now you have the coefficient of u as 120. To eliminate u, I will apply the operation of subtraction. So I'll do equation 1 minus equation 2. That will give me 120u plus 176v is equal to 40 minus 120u plus 165v is equal to 39. Or you can think of the second equation having a bracket. So when you open the bracket, the minus sign goes in and affects the sign of the terms. Minus into plus will become minus, minus into plus will again become minus, minus into positive 39 will again become minus 39. Now we apply the operation 1 plus 1 positive number, 1 negative number, subtraction 11v, sign of the greater number, so positive 11v is equal to 1 positive number, 1 negative number, operation will be negative. 1 positive number, 1 negative number, operation will be subtraction. 40 minus 39 is 1. We will apply the sign of the bigger number, which is 40, so plus 1. So you have 11b is equal to 1, which implies b is equal to 1 upon 11. Now we know the value of v. Let's substitute in equation 1 to figure out the value of v. 30v plus 44v is equal to 10. 30v plus 44 into v is 1 upon 11, which is equal to 10. Implies 30v plus 44 upon 11 equal to 10. Implies 30v plus 11 ones are 11 fours are equal to 10. Implies 30v is equal to 10 minus 4. Implies 30v is equal to 6, which implies v is equal to 6 upon 30. 6 ones are 6 fives are. So u is equal to 1 upon 5. So now you have the values of v and u. Remember, our task was to figure out the speed of the stream and that of the boat in still water. So those are represented by the variables x and y. We have only figured out the values of v and u. Now we need to use them to figure out the value of x and y. So u is equal to 1 upon 5 and v is equal to 1 upon 11. And u is equal to 1 upon x minus y and v is equal to 1 upon x plus y, which is now equal to 1 upon 11. So you again have two equations that you need to solve. These are simple ones. All you have to do is cross multiply and you will get 5 is equal to x minus y, or x minus y is equal to 5. Similarly here, 11 is equal to x plus y, or x plus y is equal to 11. Now again, let's apply elimination method and eliminate y. We figure out the value of x by adding both the equations. So I'm adding equation 1 and 2. A form of equation 1. Adding 1 and 2, we will get plus will not make a difference. The signs will stay the same. Plus times plus is plus, plus times plus is plus, plus times plus is plus. So you have 2x minus y and plus y, they cancel out, is equal to 5 plus 11, which is equal to 16. That implies x is equal to 16 upon 2. So you have your first answer. The speed of the boat in still water is 8 kilometers per hour. Now, substitute this 8 into any one of these two equations to get the value of y. Let's use this. So, which means x 8 plus y is equal to 11. Implies y is equal to 11 minus 8, which is equal to 3. So you now have the speed of the stream, which is 3 kilometers per hour. This is how you finally land on your answer. So just to recap, we started off by figuring out the unknown variables, unknown quantities, unknown parameters, representing them with variables. In the next phase, we figured out the linear equations that would help us reach the solution. We converted the first two statements into linear equations using the relationship between speed, distance and time. Since both the statements were expressing the total number of time a boat takes to travel a certain number of kilometers upstream and downstream, we thought in terms of time while making the linear equations. The next phase, we solved the two linear equations with the help of small substitution. The variables used were v and u. Using elimination, we figured out the values of v and u. And using the values of v and u, the last phase of the question, we figured out the values of x and y, the speed of the boat in still water, and the speed of the stream.